So hello again and welcome to the second part of the GATE chemistry question 1 marks question solution, the organic chemistry part. So as you can see in this question, we have got the substrate an aldehyde and which has been reacted with PH3P CBr4 ET3N as the base and CH2Cl2 as the solvent to yield Q, and we have to talk about the mass spectrum signature of this compound Q. So whether the molecular ion peak M plus 2 and M plus 4 have a relative intensity of 1:2:1 or 1:3:1, or M and M plus 2 has a relative intensity of 1:1 or 2:1. So the options has been given and you've seen the question. So this is actually a name reaction, which is the Cordyfox alkyne synthesis, and the reaction given to us in the question is actually the first step of this Cordyfox alkyne synthesis. So we'll learn the Cordyfox alkyne synthesis in details in a future video. So here what we see is that the PH3P actually attacks the bromine of CBr4, and hence we get an halide which is the PH3P plus Br minus and CBr3 minus. And after that what happens is that this CBr3 minus undergoes alpha elimination to yield the carbene, which is the dibromocarbene, and then this dibromocarbene ultimately actually gets undergoes a nucleophilic attack from PH3P, and this nucleophilic attack in turn yields the halide, which is the PH3P plus CBr2 minus. So this halide it actually reacts with ultimately reacts with the carbonyl compound, which is the aldehyde group. So you can understand that this reaction or the mechanism of this reaction is almost quite similar to the Wittig alkene or Wittig olefin synthesis. So then, as I said, what we see is that this PH3P plus and CBr2 minus, this reacts with the aldehyde group, and we get the tetrahedral intermediate, which contains an O minus and the PH3P plus. So then a PO bond is formed, and this yields a 4-membered cyclic, a little bit unstable intermediate, and this intermediate then undergoes ring opening, and we get the C double bond CBr2 part of the compound. So where PH3PO is going out as a leaving group. So this final compound that we have, C double bond CBr2, actually has got 2 bromine atoms, and as you know, the isotopic pattern of 2 Br atoms present in a substrate in a mass spectrum. So Br has got like 2 isotopes, which is 79 mass number and 81 mass number. So there is a difference of 2 units, and hence we understand that the signature, that is M is to M plus 2 is to M plus 4, would be 1 is to 2 is to 1, and which is the correct option. So the option A is actually the correct option in this question. So thank you, and let's go to the next question. So in the next question, we have actually been given a substrate which has got like 2 phenyl groups in 1 carbon and 2 aryl groups in 1 carbon, and they have been subjected to photochemical condition to yield M. We have to find out what this major product M is. So the aryl group has been given as the cyanobenzene group. So as you can see, in the initial steps of solving this question, we can eliminate option B and option D, because they do not have the 2 aryl or 2 phenyl in 1 carbon atom. Okay, next we see that there is this cyanobenzene group. So this is the more radical stabilizing group in comparison to phenyl, and this reaction is the name reaction, which is actually known as the dipymethane rearrangement. So you can find it in any standard organic chemistry book. So what we see here is that firstly homolytic cleavage takes place and radicals are generated, then there is a cyclic ring formed, and after that what happens is the more stable radical stays with the 3-member cyclic ring. So yeah, so ultimately this is the answer. Thank you.